The chair will now recognize himself for 5 minutes. Mr. Simmons, how specifically has the DOE changed its priorities to fund more early-stage research and technological development?
In the areas that I outlined, it makes sense to spend money, say, on concentrated solar power for the value of that it can have to grid reliability, for things like power electronics, because power electronics are really the bridge between power cells and the electrical grid, and it can provide, and better power electronics can help provide important services to the grid. So those are two ways, as well as working for solar forecasting to make sure that we're focused on these making sure that we have better solar forecasts so that solar is better integrated into the grid. So it is making sure that we focus very much on this, earlier stage projects and less on deployment.
All right, thank you. Dr. Keller, you've heard the department's announcement to focus more on early stage research within EERE.
Yeah.
Okay. So what impact could this refocus have on the direction and projects undertaken at your lab?
So as I outlined in my testimony, we have a lot of early stage research going on. So I applaud the department for focusing on the early stage. This said, I think it's also important that we having a balanced portfolio. I think it's very important that we looking holistically into this research, because you need to look at this in an integrated way. So I think we need to continue to drive early stage research to de-risk some of these new technologies, what industry cannot do. And then we also have to have a research portfolio to help to transition this technology to industry.
You mentioned several areas of fundamental science in your testimony.
Yeah.
Can you explain how these areas help the solar industry?
I'll give you perovskite as an example. This is a very early stage research. If we are successful to overcome some of the limitation on these materials, their stability concerns, for example, moisture sensitivity, this will lead to a revolution in the way we're making solar cells. So I showed you this, that you can use this so-called roll-to-roll, that you can produce solar cells in the way you're doing newspapers, because this will lead to an ink. So suddenly you can have solar panels in ways, in areas where we even have no chance right now to go into. So this is one of this, what I call game-changing technologies.
Not to mention the rapid production.
That's exactly what this is, roll-to-roll. Right. So it's almost like an ink. So you bring this down to a carrier like you would bring down ink onto a newspaper. This can be a revolution in the way we're making solar panels.
Sure. Mr. Stein, you talked about the proper role of federal government. So in your opinion, what is the proper role of the federal government when it comes to funding priorities for applied energy research?
Well, I think the category that I sort of outlined is that the idea that this is something that is not being funded and will not be funded by private interest or individuals.
Well, should we preempt that with the need for it first?
Well, the need for it, I think that
you have to have a need before you decide you want to go into research how to fix that need. True stuff?
Yes, that's certainly true. But the part of the problem with the government funding all these things is knowing what that need is.
Right.
The government isn't necessarily good at identifying those things.
Heck, you say.
You could have private companies can think of novel applications for some of these things that the government just doesn't have the capacity or the management process to come up with those.
So when that need's identified, when that process is identified, should the federal government fund late-stage consortiums where industry is already involved in developing solar energy technology?
Well, I would say no, simply because once it's already the technology is proven, once the data and research is there, it's private companies going out and finding a way to economically produce that and apply it in the private market.
Thank you. I've got about 30 seconds left, and I want to just make a couple of observations. I think there's about 4 steps to this, and Dr. Eglash, you may be the best one. You had the degrees in engineering, right? It seems like there's 4 steps to solar. Concentrate it, capture it, store it, and then release it efficiently. Is that fair?
Yes, that's fair.
Okay. So Where do you think, very quickly, I'm out of seconds here, but where do you think the most innovation needs to happen out of those four?
There's still a lot of opportunity for innovation in making solar panels better, more efficient, and lower cost and longer
So
lived.
that's the storage part that could release it efficiently.
That's the process of converting sunlight into electricity, the amount of electricity that we can produce for a given panel or a given dollar invested. And then integrating that electricity with the rest of the electric grid, with storage, with loads in buildings.
That's the releasing it efficiently part.
That's right.